Hello, hello, happy Monday, pre-calculus. Here's our first ed puzzle video of semester. So, compound interest formula. Review from Algebra 2, I hope. If P dollars is invested at a rate R, expressed as a decimal. Okay, so what are we saying here? So if you are going to invest, say, $1,000, P stands for principal. This is basically your investment. And you're going to invest it that's going to in some sort of account that's going to earn interest. And say it earns, I don't know, 6% a year. So if you have an interest rate of 6%, you want to express that as a decimal. You want to express that as 0.06. So that's what this is saying. And then you're going to invest the money for some time period, T, and you're going to earn money on your money. So as it sits in the bank, let's say the bank is going to pay you for you letting them hold your money because they're not holding it, they're investing it and making money on it. So they're going to pay you a little bit for that, and that's called interest. So they're going to have it for some time period, T, and then it's going to be compounded in times per year. Okay, so what does that word compounded mean? Basically, that means how many times a year your interest that you've earned goes back into your principal or back into your original investment. I guess I should say original investment. Principal. And so let's say if the interest is compounded once a year, it would take a whole year to earn interest, and then you would take that 6% that you earned and it would go back into your original investment. All right. So let's say, you invested $1,000 and it's in there for a year and it's compounded. What did I say? 6%. And so it earns, what's that? $60. Okay. And so $60 then goes into the original investment. Your now original investment is thought of as $1,060. And then the second year you're earning interest on $1,060 and not just $1,000. All right. So you want to compound more often than not. You want your interest to constantly be rolling back into your original so that you are earning money on more money. Okay, so if you have the words you might hear for compounded, you might see quarterly, and that would be, 4 times a year would be your N equals 4. You might see monthly, and that would be 12 for your N, so on and so forth. All right, so let me get my TI on here because we're going to be using it. And our formula then is amount. So this is your amount, your new amount. You get your principal. Obviously, you're not in the stock market. You're not risking losing money with this situation. You've got your principal, and so your amount will include your original, and then you're going to earn times 1, because you're going to keep your principal, and then you're going to add in the rate. So that's your 1. You're going to keep your principal and then add in the rate in decimals. And the rate, if it were just yearly, you would just say that 1 plus 0.06. But with compounding, you're going to split the rate. So let's say you are you're compounding twice a year. That rate would be split by 2. So if it were 6%, that would become 0.03. So it's getting split into 0.03 because it's happening twice a year. All right. And so to kind of counteract that lower rate exponentially, you get raised to the NT. Okay. And so that takes your time. So if it were like, 3 years, 3 years gets increased by times 2. Your time becomes 6 because that's the amount of times it's getting compounded over that time. So although you split the rate, it gets counteracted up here by the multiplication by the time, if that makes any sense. It's not very technical, but it's just a way to think about it. All right, so here we go. Penny wise, Penny's very wise here. She is going to invest $12.50 at 8%. So you want to make sure you put 0.085 Compounding quarterly, that's a 4. Find the balance after 3 years, so 4 times 3. That's it, folks. Super easy. Memorize the formula, and you'll be good to go with this little topic. All right, so what do I have? 1250, or T, I can take it all, times 1 plus 0.085 over 4, all to the 4 times 3. You want to have that in parentheses up there. Sorry, you couldn't see that. So there's 1250, your parentheses 1 plus that rate divided by quarterly compounded up arrow. And you could have just put 12 here, but I put 4 times 3 to show the need for the parentheses there. If you're not going to multiply it first, you want to enclose it in parentheses. Hit enter. And so Pennywise ended up with 1608.77. So there you go. She earned a little over $350 on her investment. Okay, so the next type of compounding is continuous. So you want to look for that word continuous. If you see the wording continuous, this is a different situation. Compounding continuous. All right, so what does that mean? It just means you're earning money on your money all the time. There's no like, okay, let's compound it daily or monthly or what have you. It's continuously rolling back into your investment. And so this is going to be a different formula. This is going to be our PERT formula. So again, your rate needs to be a decimal. So convert that, shift that decimal over 2 to the left to convert, and look for the word continuously. And this formula is a little different. So P is your principal, and now instead of the 1 plus the R, this naturally occurring value of E comes into the situation, and it's E. E has a value just like pi. So if you look here, you can get E by second over the division sign. E is equal to 2.718, we'll say, 2.718. But usually you're going to be getting E from right here above the ln. And that's E raised to the first power, 2.718. It's kind of like pi, you know, it's a naturally occurring value in a circle, and this is a naturally occurring value in exponential situations, okay? So this is 2.718. Okay, so if we were to graph the graph of y equal E, this is a little bit of a review here. If we were to graph this, e to the x is just, you know, if you were to plug in 0, you'd get e to the 0, which is 1. You're going to have that key value once again, guys. And remember, this base is 2.718. So it's going to be exponential growth, and it's going to look just like all of our other ones. So that's how the graph of y equals e to the x shakes out. No surprise there. All right, so now Homer is investing. He's investing $2,575, and continuously is that key word here. And so I'm going to put E into the problem. I'm going to shift that decimal 2 places, 0625, and our years would be 5. Okay, and PERT's really easy to deal with. It's called PERT as kind of a little shortcut. That doesn't show the exponentiation of the R&T, but you'll hear teachers mention PERT. All right, so this is just, let's clear that out. 2575. We're going to go second E, raise that to the 0.0625 times 5 in the parentheses there. So can you see that? And there you are. Mr. Homer got his 3519, so 3,509.60. There you go. Okay, so I'm going to pause this for a second because my phone is continuously ringing, so I'm going to pause for a second. Okay, I'm back. There was no emergency. All right, so one thing I did notice, though, here is I should have rounded this to 1. All right, so let's change that, and we'll go on to the last problem. That certainly would have rounded to 1. All right. So now let's go here and do this B. This is just an application problem of this. How long will it take for an investment to double if it's invested at 6.25 and compounded continuously? We're going to solve this graphically. All right, so we're going to write PERT. All right, and so we go through this. What amount do, you know, we're going to want our amount to double, but what's our principal? I don't know. I don't know my principal. I know E is E. Um, I know my rate is 0.0625, and I'm looking for how long. So I don't want to plug in for T. This is what I'm solving for. So I want T to be in the problem. Okay, so how long will it take for investment to double if it's invested? So you've got this A and P. So you're going to use, I'm going to talk you through this hypothetically. So let's say we had $5, and we wanted to double it, and we wanted it to go to 10. Your first step here would be to divide both sides by 5. And when you divide this side by 5, because this is just being multiplied, and this side by 5, you're going to get 2. Okay? So let's say you are putting in $1 million here, $1 million, and you want to get 2 million here. Well, the first step is you're going to divide both sides by 1 million, and you're going to end up with 2 here. So let's just pretend like we're investing $1, and we want $2. So with the doubling, you're going to be, setting 2 over here because you're basically thinking I want $1 to double. This is your keyword with doubling is going to have you have this 2. Any situation, principal doubling, you could even write P and 2P. And, if you want P here, and then that would be 2P, you divide out the P's, you're left with 2. So either way, the time will be the same. It'll take $1 the same amount of time to double in this situation as it would $1 million to double in this situation. So we're going to solve this graphically. We're just going to set these equal to each other. So the first graph is going to be a 2 because we want to see where this situation crosses 2. All right, so this is 2. And we just graph the line y equal to 2. And then we graph e to the 0.0625t. All right, and so here we go. So let's go here and graph. That's where I did it yesterday before I lost sound. Anyway, so we're going to put in e to the 0.0625, and instead of t here, we're going to use x. Put that all in parentheses so the calculator knows what to do. Okay, so you go and graph, and I've already changed my window again when I did this problem yesterday, before I realized I had no sound on. So I'm going to go to Zoom 6. I'm going to go to Zoom 6. Oops. Zoom 6. And so what would happen here is if you had a Zoom 6, you would see this, which is not, you can't really see that it's crossing. So you're going to want to switch your window. So let's do a window of 0. I don't need to go into negative time. And let's go over, 25 years or something. And then we don't need to go below, so we could just do something like, I only want to go as high as 2, so maybe I'll do 5. So this is 0 to 25, and then 0 to 5. Okay? So we're still going to have that key value right there, and graph it, and so you can see exactly what I have depicted here. And so what we're looking for is this point. We're looking for this point. This point will be sometime where we equal 2. So remember from semester 1, we go to second, trace, intersect, punch, punch, punch. It's asking you questions, but you just say yep, yep, yep. And the intersection is 11.09. 11.09 and 2. Okay, so 11.092. So that is, the years would be 11.09 years. We will be at 2, which means it will double. All right, so have a good rest of your Monday. I hope that puzzle was easy, and I'll look forward to seeing you guys in class. Bye.